Artificial intelligence. Learning like machines do. When we humans learn, we experience the world around us. We interact with our environment, absorbing information through our senses. This process is deeply personal and unique to each individual. We observe, we try, we fail, and we learn from our mistakes. This trial and error method is fundamental to human learning. It's how a child learns to walk, how an artist perfects their craft, and how we all grow and develop over time. Artificial intelligence, or AI, learns in a different way. Unlike humans, AI doesn't have senses or emotions. It doesn't experience the world directly. Instead of feelings and experiences, AI relies on data, massive amounts of data. This data is processed and analyzed to find patterns and make decisions. Think of data as the building blocks of AI learning. Each piece of data is like a tiny brick that, when combined with millions of others, forms a complex structure of knowledge. AI systems use this data to find patterns and make predictions. They analyze vast datasets to identify trends and correlations that might not be obvious to the human eye. Imagine you are teaching a computer to recognize pictures of cats. This is a common example used to explain machine learning. You show it thousands of cat pictures. Each picture is a piece of data that the AI will analyze. The computer analyzes these pictures, identifying features like pointy ears and whiskers. It looks for common characteristics that define a cat. Over time, the AI system builds a model of what a cat looks like. This model is based on the patterns and features it has identified from the data. This allows it to recognize cats in new pictures it has never seen before. The AI can generalize from the data it has been trained on to make accurate predictions about new data. This process of learning from data is called machine learning. It's a subset of AI that focuses on the development of algorithms that can learn and make predictions from data. It is a powerful tool that drives many AI applications we use every day. From voice assistants to recommendation systems, machine learning is at the heart of modern AI. However, this learning process is fundamentally different from how humans learn. Our learning is influenced by our emotions, experiences, and interactions with the world. We understand the world through our senses and emotions. These experiences shape our understanding and knowledge in ways that data alone cannot replicate. AI, on the other hand, relies on mathematical models and algorithms. These models are designed to process data and make decisions based on statistical analysis. This difference is important to remember as we explore the capabilities and limitations of AI. Understanding how AI learns helps us appreciate its strengths and recognize its limitations. Algorithms, the recipes of AI. Just like a recipe guides a chef in creating a delicious dish, algorithms guide AI systems in performing tasks and solving problems. Imagine a recipe for baking a cake. It provides a detailed list of ingredients and step-by-step instructions to ensure the cake turns out perfectly. It tells you the ingredients you need and the steps to follow, from mixing the batter to baking it at the right temperature. Algorithms are like recipes for AI. They provide a set of instructions that AI systems use to process data and make decisions, much like a recipe guides a chef. These algorithms are essential for AI systems to function effectively. They help in analyzing vast amounts of data, identifying patterns, and making informed decisions based on that data. There are different types of machine learning algorithms, each designed for specific tasks and types of data. One type is called supervised learning. This method involves training the AI system using labeled data, where the correct answers are provided during the training process. In supervised learning, we give the AI system labeled data. For example, we show it pictures of cats and dogs, and we tell it which ones are which. The AI system uses this labeled data to learn and improve its ability to classify new pictures correctly. Over time, it becomes more accurate in identifying cats and dogs. The AI system learns from this labeled data to classify new pictures correctly. This process is crucial for applications like image recognition and language translation. Another type is unsupervised learning. Unlike supervised learning, this method does not use labeled data. Here, the AI system is given unlabeled data. It must find patterns and relationships on its own, without any guidance on what the correct answers are. It must find patterns and relationships on its own. This type of learning is useful for tasks like clustering customers based on their behavior or identifying anomalies in data. For example, an AI system could analyze customer data and group customers with similar buying habits. This helps businesses understand their customers better and tailor their marketing strategies accordingly. This helps businesses target their marketing efforts more effectively. By understanding customer segments, companies can create personalized marketing campaigns that resonate with specific groups. Finally, there is reinforcement learning. This type of learning is inspired by behavioral psychology and involves learning through trial and error. In this type, the AI system learns through trial and error. It receives rewards for good decisions and penalties for bad ones, gradually improving its performance. It receives rewards for good decisions and penalties for bad ones. This method is particularly effective for tasks where the AI needs to make a series of decisions, such as playing a game or navigating a robot. Think of training a dog. You reward it with a treat when it follows a command. Over time, the dog learns to associate the command with the reward and performs the desired behavior. You reward it with a treat when it follows a command. Similarly, an AI system using reinforcement learning learns to make better decisions over time by receiving rewards and penalties. Over time, it learns to perform the desired behavior. This approach is used in various applications, from training autonomous vehicles to optimizing supply chain logistics. Similarly, an AI system using reinforcement learning learns to make better decisions over time. By continuously improving its decision-making process, the AI becomes more efficient and effective in its tasks. The boundaries of AI learning. While AI has made remarkable progress, it's important to remember its limitations. Current AI systems excel in specific tasks they are trained for. A chess-playing AI can beat grandmasters, but it can't write a poem or understand a joke. One key limitation is the need for massive amounts of data. Humans can often learn from a few examples. We can see one or two cats and then recognize any cat we encounter. AI systems, however, require thousands or even millions of examples to learn effectively. Another limitation is their inability to generalize well. An AI system trained to recognize cats in photos might struggle to identify a cat in a cartoon drawing. Humans, on the other hand, can easily adapt their knowledge to new contexts. These limitations highlight a crucial point. AI learning is not the same as human learning. While AI systems can achieve superhuman performance in specific areas, they lack the flexibility and general intelligence of humans. Section 4. The illusion of AI self-learning. We often hear about AI systems learning on their own. This phrase can be misleading. While it's true that AI systems can improve their performance over time, they still rely on humans for their initial programming and the data they learn from. Imagine an AI system designed to write news articles. It can analyze thousands of articles and learn to mimic the style and structure. However, it cannot come up with original news stories on its own. It relies on the data it was trained on, which ultimately comes from human journalists. The idea of AI self-learning creates an illusion of autonomy that doesn't truly exist. AI systems are tools, and like any tool, they are only as good as the humans who create and use them. Understanding this distinction is crucial. It allows us to appreciate the power of AI while remaining realistic about its limitations. We should avoid anthropomorphizing AI systems and attributing human-like qualities to them. Section 5. Data versus understanding, a key difference. Imagine reading a book about cooking. You might find yourself engrossed in the vivid descriptions of recipes, the colorful images of dishes, and the detailed steps laid out for you to follow. You can learn the steps to follow, the ingredients to use, and the precise measurements required for each component. The book might even delve into the science behind different cooking techniques, explaining why certain methods work better than others. But simply reading about cooking doesn't make you a chef. You might understand the theory, but without practice, the knowledge remains superficial. To truly understand cooking, you need to experience it firsthand. You need to get your hands dirty, make mistakes, and learn from them. You need to feel the textures, smell the aromas, and taste the flavors. This sensory engagement is what transforms knowledge into understanding. This distinction between knowledge and understanding is crucial when we talk about AI. While AI can process vast amounts of data, it lacks the experiential learning that humans undergo. Current AI systems are incredibly good at processing information and finding patterns. They can sift through enormous datasets and identify correlations that might elude human analysts. They can analyze vast amounts of data and make predictions with remarkable accuracy. This capability has revolutionized fields like finance, healthcare, and marketing. However, they lack the deep understanding that comes from experiencing the world as humans do. AI can recognize patterns, but it doesn't comprehend the context or the meaning behind those patterns. AI systems can recognize patterns in medical images, identifying anomalies with high precision, but they don't understand the human body or the experience of illness. They can translate languages with impressive accuracy, but they don't grasp the nuances of culture and emotion embedded in those languages. The subtleties of human communication often elude them. This fundamental difference between data-driven learning and true cognitive understanding represents a significant hurdle in AI development. Bridging this gap is one of the biggest challenges facing researchers today.